In this video, we're going to continue our lecture on partial fraction decomposition. This should be part 2 of a video we've already produced on this topic. Again, the idea of partial fraction decomposition is to go from a combined fraction back to simpler fractions that were added or subtracted to make that fraction. You can review through the process. Let's look at another type. This is also a proper fraction. Given you have x times x squared in the denominator, that would be x cubed. Your power of x in the numerator is x, so there's no division or anything that needs to take place here. However, if you look at your factors, you now have a linear factor of x plus 1, but then this is a quadratic factor that is non-reducible. This cannot be factored down any further. So your decomposition setup is going to be a little different. So we have the x plus 1, so that's just a linear factor, so we'll do the a over x plus 1. But since we have a quadratic factor, x squared plus 2, my numerator needs to be a linear setup. So it needs to be bx plus c. So like a linear term and a constant. So if this was x cubed, then we would need a bx squared plus cx plus d, etc. So we're going to do the same process we did in the other video. I'm going to multiply through by the common denominator to clear out the fractions. So that would give me 2x plus 1 equaling a times x squared plus 2 plus b x plus c times x plus 1. All right, let's try to find the a, b, and c. The first thing I'm going to do is let x equal negative 1 like I did in the previous examples. So you can maybe possibly extract one of your letters or one of your variables a, b, or c from this. So if I let x equal negative 1, that would give me negative 2 plus 1, which is negative 1, equal to, in this side, if I do negative 1 squared, that's 1 plus 2 would be 3a. So in the other set, if we let negative 1 be right here for x, that would give me a 0, so all this will become 0. So in that case, we know if we divide by 3, a will equal negative 1/3. And it is possible to have a fraction, so that's okay. A is equal to negative 1/3. Now, I can't set this one equal to 0 and use a number that would give me, nothing's going to ever give me 0 for this factor. So let's talk about terms. How about x squared terms? Compare what we've got. There are no x squared terms on the left side, so it's going to equal 0. Now, if we have an x squared term here, so 1x squared times a, so we have an a that has an x squared term. Now, if I were going to multiply this out over here with FOIL, bx times x would be bx squared. So I could also have a b with an x squared. And I believe that's the only place in this setup that you would get x squared. All the other ones would just have x to the first. So a plus b equals 0. Well, we know what a is. So b must be 1/3 positive. But we still haven't found c, so let's look and see kind of what we could use to find c. C in this case, if I said bx squared, bx, cx, and then c is a constant. So we could use the x terms, maybe just the x terms, and see if that will help us find c. So if we do that, the x terms, it would be 2. 2 is the only x term I have on the left, equal to, there are no x terms in this part. Over here, I would have bx squared plus bx, so b, plus cx, so plus c, and then that's not got an x, so it's just b plus c equals 2. So 2 equals 1/3 plus c. So if I subtract 1/3 from both sides, I would get 5/3. So C is equal to 5/3. So my partial fraction decomposition would be -1 over, for the x plus 1, we will have, I could do the -1/3 on top just like it is. I'm just going to be, so that would be 1/3 x plus 5/3 over x squared plus 2. Now, to be more correct here, since you don't want an improper fraction here, or not an improper fraction, but a complex fraction, we're going to move those denominators down to the denominator with the factor you've got. So this would actually look better if we had -1 over 3 times x plus 1 plus 1x plus 5 over 3 times x squared plus 2. That would actually look better. Okay? Let's try a couple more. This one is the first example that I've done that actually involves an improper fraction. If you'll look, your highest power of x on the denominator is 4. Your highest power of x in the numerator is 6. So according to our instructions, we were told to divide first to simplify this out to see what we could do. So let's divide x to the 4th plus x squared into, I'm going to do this up here so I have better room. I'm going to divide x to the 4th plus x squared. Long division style here. We haven't done this probably in a very long time. So let's see what we get when we divide that out. What would I multiply x to the 4th by to make 3x to the 6th? Well, I can multiply it by 3x squared. 3x squared times x to the 4th would be 3x to the 6th. And 3x squared times x squared would be 3x to the 4th. But we bring down and subtract, so subtract. Bring down our next term. Well, I can't divide x to the 4th into that, so that's my remainder, just the 3x. So what we'll have here, since we got the divisor of 3x squared, we're going to say that this is equal to 3x squared plus 3x over x to the 4th plus x squared. The remainder over the divisor. Now, the only part that we're going to, so this will be part of our answer here. We'll have to just put that in our answer. The only part we're going to have to work with now is the 3x over the x to the 4th plus x squared. So let's try to simplify that down a little bit. I could factor out an x squared. And I'll be left with x squared plus 1. So my partial fraction decomposition, for the x squared, we would have to have an a over an x. And then since it's x squared, b over x squared. And since we have the quadratic factor x squared plus 1, we'll have to have a linear combination cx plus d over the x squared plus 1. Now, I'm going to multiply through by the common denominator. Let's go to the next screen here to do this. So I'll get 3x equal to a times, let's go back. Okay, one x would cancel out, so I'd have an extra x and an x squared plus 1. plus b times c. The x squared would cancel out. We'd have x squared plus 1 plus cx plus d times x squared only. So since we did have a factor of x and x squared, we can let x equal 0 and see if we can get anything out of that. So if I let x equal 0, 0 would equal, this whole term would go to 0 because of that factor right there. Okay, if I let, I'm not going to put that in there. I don't have to put that in there. 0 plus 1, so b. And if I put 0, that's going to make all those go away. So b is equal to 0 altogether. So we have no b involved in this problem. Okay? Let's look at our terms here and see if that'll help us. X squared terms. There are no x squared terms on the left, so we got 0. If I were to multiply this together, ax times x squared would be x cubed. Don't want that. Ax times, there would be no x squared terms in this setup. Bx squared. So there's no x squared. There's bx squared there. And this one, cx cubed plus dx squared. So c plus b plus d is equal to 0. We know that 0 is equal to b, so d has got to be equal to 0 also. So we're not getting very far with this. Let's try the x terms. 3 is the sum of all the x terms on the left, so let's see if we can get x's over here. Ax cubed, no. Ax, so a. Bx squared, b, no. No x's there. Cx cubed, dx squared, so no. 3 is all we can get for a there. So I'm trying to find c. So let's use cube terms. X cubed. And since we don't have any on the left side, 0 equals a, because we would get an ax cubed. Ax, let's say no cubes here. Cx cubed, so plus c. So 0 equals 3 plus c, so c must equal negative 3. So the only coefficients we were able to even solve for was a and c. So going back to our setup, a and c, a is 3, c is negative 3. So a was 3. C was negative 3. B was 0, so that's going to all go away. The D is not there anymore. So the partial fraction decomposition, I'm going to write this in a different color so you can see it, would be the 3x squared. So 3x squared that we had to start with, okay, plus 3 over x, and then minus 3 over x squared plus 1. So if you have to divide out to start with, that's a little harder of an extra step.